This is the prep packet video for Unit 4, Chapter 9.2, and we'll be looking at objective number 1. In objective number 1, we're going to work on evaluating expressions that look like this. What you have here is the variable, that's the base, and then you have an exponent that is a fraction. These are called fractional exponents, or sometimes they're called rational exponents. And what we're going to be working with right now are the very basics, and there is a pretty handy way of doing this. You can look at this sort of a setup, a to the 1/2, and you can transform that into the square root of a. Remember, when we write the square root of a, we're leaving out the index, which is 2. We understand that that's the basis of that. What's interesting here is that the denominator of this fractional exponent is the same as the index when you're using it as in radical form. So if a to the 1/2 is written as the square root of a, then you can think that a to the 1/3 is the cube root of a. Again, here's the denominator, here's the index. What's nice about this is it makes it pretty easy to start working with exponents. You might be kind of leery of doing this. But you might be more interested in doing a to the 1/4, I should make that times 2a to the 1/4. Because all of a sudden it's a lot easier to add these because we have rules about fractions and combining those that we don't really have for dealing with radicals. So here is something I want you to really pay attention to in your notes. Here it talks about rational or fractional exponents are an alternate way to express roots. So here you have an example of x to the m over n, and here you have there is the denominator and there is the index. The numerator on this belongs inside for the moment with that variable there. And remember, that's only because, and you can never have a 0 here because we can't divide by 0. Pardon me. So when you're dealing with a radical expression, you can convert it into an expression that has a fractional or rational power. One thing, and I keep saying this, the denominator of the fractional exponent is the index of the radical. So there's the denominator, there's the index. Really, really important. I'd also like to mention now that I've gotten a lot of these graphics from the Regents Exam Prep Center, and here's their website. This is a very, very helpful website developed by people in the state of New York to help students prepare for the Regents Prep exams. That's the basics of what we're doing in this particular objective. So let's take a look and practice and work along with me on your prep packet. I want to refresh your memory from an earlier video, the idea that if you have an even exponent, even index, and it's positive inside, what comes out will be a positive number, and that's the principal root. If you have a negative out in front of everything, then that affects that and makes it the negative root. If you have an even index and a negative number inside, it is not a real number. If you have an odd index and any number, then you only get one root. So if it's -5 inside, it's -5 outside. So let's take a look at these. First, we're going to rewrite them. So this is 9 to the 1/2. I'm going to put it in a radical. There's 9 on the inside. The denominator is 2, so the index is 2. The square root, and normally you wouldn't write that, but I am for now. And the square root of 9 is 3. And just to double check, I had an even index and a positive number, so I'm only going to write the positive root. Here I have the fifth root of 32. So again, I have the index, the denominator, and the index will be the same thing. So I have 5 out here and 32. And there are a couple of ways you could figure this out. You could do it the long way. I know it's going to involve 2's. You could look at a chart and realize that you knew what was going on with 32 and the relationship it has with 2. Or I could even do this. I know that 2 squared is 4 times 2 squared times, so that would be 4 times 4 times 2. That's 2 to the 1. 1 plus 2 plus 2 is 5. So the fifth root of 32, and this is positive, so my answer will be positive, is positive 2. Here I have negative 16 to the 1/4. Keep in mind that this is not the same as this. Okay? What that says is take the fourth root of negative 16. What this says, and this is where we're going with this says first take the fourth root of 16 and then make it negative. So again, I'm trying to find the fourth root of 16. 2 squared times 2 squared. 2 plus 2 is 4. The fourth root of 16 is positive 4 because I'm looking for the principal root. And then I'm going to make it negative. So the answer here would be negative 4. Let's take a look at this. This is the same as the cube root of 27. Again, index and denominator match. The cube root of 27 is 3 because 3 cubed, or 3 times 3 times 3 is 27. Here, this is slightly different than this, and this you would write as negative 144 square root. But here you have a problem. This is even, look down here, and this is negative. If this is even and this is negative, it's not a real number. Here I didn't write that very well, but I think you know what I mean. Here I have inside is negative 32, outside is the fifth to the fifth power, or to the fifth root. Again, I have it's odd here and any number. So we learned up here that, and I always do this, if I've already done the work once, I'm not going to come back and do it again. Up here I had, what's the fifth root of 32? It was 2. So what's the fifth root of negative 32? It's negative 2. So go ahead and copy, and I'll see you on the next video.